This is the notes for the 2.3 measures of central tendency, mean, median, and mode. Measure of central tendency is a value that represents a typical or central entry of a data set. The mean of the data set is the sum of the data entries divided by the number of entries. To find the mean of the data set, use one of the following formulas. If you're looking for population mean, we use the symbol mu, and it's equal to the sum of the x's divided by the number of entries that you had. So if there were 5 entries, n would be 5, and you would add up those 5 entries for the top. Sample mean is x bar, and it equals to the sum of the x's, all of the data entries divided by how many data entries. So the formulas are identical. The difference is which symbol are we using? Are we talking about population, or are we talking about sample? The lower Greek letter mu is formed by making basically a U with a big tail on it. It represents the population mean, and X with a bar above it represents the sample mean. In our calculators, every time we use the calculator's functions to actually find mean, it will always show the symbol X bar. Whether we're talking about population mean or sample mean, this is what the calculator calls it. So it's used for both the population and the sample mean. So I'm using problem number 1 from the 2.3 assignment as the example for this. This is SUV with the maximum number of seats in the sample of 13. 13 is our N of the utility villages, and whatever our answer is, we want to make that rounded to the 100th place, which means 2 decimal places. These are the samples, so they look at 13 different SUVs and counted the number of seats that they had it, so that one had 6, one 5, etc. That is representing by our X's. In our calculator, we would put X at the top of the column and then type in all of these data points in the list. I'll show you how to do that here in a minute. X bar is equal to the epsilon X, which epsilon is the symbol for sum of. So sum of the X's divided by N. And we can see where you just literally add up every single number, including the 8, and then divide by how many there were, which was 13. And again, I wrote n is 13 here to show you that that's where that came from. So X bar is equal to the sum of the X's over N is equal to 81. That's the sum of the top, divided by 13, which gives us 6.2032307. And I wanted 2 decimal places, so the answer in there for problem number 1 on the assignment in the Google form is 6.23. Okay, so how would we do that on our calculator? So you would just put in a fraction and then add up all your data points on the top. So 6 plus 6 plus 9 plus 9 plus 6 plus 5 plus 5 plus 5 plus 7 plus 5 plus 5 plus 5 plus 8. And then over what your n was, which was 13. And it will give you 81 over 13, which is what we found. To get it into fraction form, simply hit Control and Enter, and you will get 6.231. And again, we want to round to 2 decimal places, so you would drop that 1 and just put 6.23. I should have had the calculator set to 3 decimal places. Most of the time, I will ask for 3 decimal places. The other way that you can do it is go to New Document, pick No, if it asks you to save. And here's what we would normally do, because most of the time our data points are a lot more than 13. So we're going to start by putting it in as a list. So that's number 4. You have to go up to the top of the column and label it. So I pick X just because it's easy. And then you would list into 1 through whatever all your data points. So again, we say 66996, 555. And I am pushing enter after each data point to make sure that the calculator recognizes it. And I know I'm correct because I was at prop 13, which is 13 data points. So I had it all in. And then you'll push menu 4, 1. Since we only have one variable, we'll put 1. We only have one list, so we'll put OK. And then here we have to put in what we labeled our column. So we called it X. And then you just go down to and click on OK. And this shows us all of the information that's related to that data. The only thing we're worried about at this point is what is the X bar. X bar was 6.231, which we found the long way and with the calculator functions. You will also be using this to find standard deviation, which is SX. the one that looks like an O with a tail on it is called population standard deviation, so we might use that, but not for this problem. N is 13. And then these last 5 always tells us the positions of different numbers if you put them in numeric order. So the minimum data point was 5, the maximum was 9, the middle number, the median, is 6. And then if you actually divided the data into 2 halves, where the median divides it in half, the middle of the first half is Q1, that's 5, and the middle of the second half is 7.5. And that gives us all the information that we would get. The only thing that your calculator will not tell you is the mode. So again, here we actually found out our mean, which was 6.23. We found out our median, which is 6. But then to get mode, we have to look back at our data and find out which data choice, 6, 9, 7, 5, or 8, had the most repeats. And in this case, it would be 5. So that should answer all of the questions for problem number 1. So the next data notes is about the median. We just discussed how you can get it on the calculator, but here's how you would do it by hand. The median of the data set is the value that lies in the middle of the data when the data is set in order from least to greatest. If the data set has an odd number of numbers, the median lands directly on an actual data point. Like right here we have it landing right on 6. If data has an even number of data points, the median of the mean is the middle of the 2 middle numbers. So if we count in, there's 6 digits, 6 possible numbers here. When we count 3 in, we land on 7 and 8. So our median is the average of those two. We add them together, 7 plus 8, and then divide by 2 to get 7.5, because the median literally falls between the two numbers. The next type of data measure of central tendency is the mode. The mode of the data is the mode of the data set is the data entry that occurs with the greatest frequency. If no entry is repeated, the data set has no mode. If the data 2 or more entries repeats and has the same amount of repetition, then each entry is a mode. If we only have 2, it's called bimodal. If you have multiple, then it's multimodal. So here's a couple of examples. On number 1s from the assignment, we had 5 had the most repeats, so it is its mode. This one, there is no repeating number, so there is no mode. And here we have 2 numbers that repeated the same amounts, and that ends up being both of them being modes. Sometimes we have data that doesn't seem to match the rest of the data. That's called an outlier. An outlier is a data entry that is far removed from the other entries in a data set. So we have 3, 7, 8, 9, 4, 12, 31, and then 5. 31 doesn't seem to fit because it's way higher than all the rest of them. We can also see that if we look at a scatter plot or a number line, all of the other dots seem to be below 15, and then 31, if I really drew this out, would be way off of the paper. So that's your outlier. Here we have scatter plots where all the dots here are kind of bunched together in this area, and then we have one that's sticking way out here like a sore thumb. So an outlier, generally, it can skew your data, so it might make it seem like there's a higher mean than there is. Then we would use something, either the median or the mode, to decide which is the best to represent it. Okay, the next couple of concepts is using what we call weighted mean or group data. And this is how you would find the mean if your data has some kind of a different weight. So one thing might be weighing another. Good example of this is how we figure out your grade for the class that you're in. So weighted grades, sometimes data sets contain entries that have greater effect on the mean than others do. A weighted mean is the mean of the data set whose entries have varying weights. A weighted mean is given by the sum of the x times its weight. So we would first multiply whatever the x is, your grade in that class on an assignment, times its weight, and then add that to all of the other ones and divide it by how many points you could have earned at that time. So where the W is the weight of every entry. This is problem number 11 on the 2.3 assignment homework. So you see that there are several different grades that went into this person's overall grade. They made certain grades on each one, and 85 on their homework, and 80 on a quiz. They made 100 on a project, and made a 93 on the final exam. But each of those different grades actually had a different weight. Homework counted for 15%. final exam counted for 25%. So there's two steps you have to do. First, you have to add up your weights, which these all added up to 100 or 1.0. And then we have to multiply the score times the weight. So 85 times 0.15 gives us 12.75. And you can think of those as like points earned towards that 100. And then we add up that whole column, and that gives us an 89.3. So our X bar mean is the sum of the X's times their weights divided by the sum of the weights. Sum of the weights. And so 89.3 divided by 1 gives us a grade of 89.3, which is what you would see in the report card. So earlier in this section, we did a frequency chart, a frequency distribution, and this is how you would find the mean of that frequency distribution. We use the formula, the sum of the X's times how frequent they are, divided by how many total N's are, the total frequency. So N is the sum of all the frequencies. So there's a couple of steps. This is problem number 13 in the homework, the daily assignment. So we first add up your frequencies. That gives you 16. So 3 plus 4 plus 7 plus 2 was 16. Then we first have to find the midpoint because we have a range. So our midpoint is found by adding the upper and the lower and then dividing by 2. So 60 plus 62 divided by 2 gave us 61. And then we got 64, 67, and 70. Then we take those two numbers, X being the midpoint, F being the frequency, and multiply them. So 3 times 61 gets us 183, 4 times 64, 256, etc. And then we add that column up to get 1048. So our mean is the sum of the X times F, 1048, divided by the sum of the F, which is our N, which was 16. So we do 1048 divided by 16, and we get 65.5. The mean frequency and the weighted mean, you cannot use the calculator's trick to do that. You actually have to do it out by hand. It takes an extra few minutes, but it's really not that more difficult. The final concept we need to talk about is the range. The range of a set of data is the difference between the largest and the smallest value. So we have 10 being the largest, 3 being the smallest, and the range is just the difference between that. This is used to actually develop our frequency tables, because if we know our smallest is 60 and our biggest is 71, and we want to divide it into 4 groups, we first have to figure out how many numbers there are between those. So 60 minus 70, or 71 minus 60 gives us 11, and then we can divide that by 4 to figure out that we need 3 numbers in each group. That's where our differences in our weights go. So that is all of 2.3 notes. The next one will be for 2.4. Okay, I almost forgot. We also need to look at the shapes of distribution. Each of the questions in the 2.3 assignment actually ask you to determine which of the 3 types of measures of central tendencies is the best for the data. So what you really have to do is look at the shape of the data. And the shape here is symmetric because it makes a heel where the mean, median, and mode are equal. So they all end up in the middle, and the mean ends up being the best data. If it is skewed to the left, the data seems to climb actually moving towards the right, where the left is falling down, and the mean ends up being less than the median. And the median ends up representing the data because it ends up in the middle. The next one is skewed to the right. This is where it's falling to the right, and the mode is more than the median. So the mean is more than the median, and the median is still the best representation because, again, it's in the middle. And then finally, we have a uniform, which is where there's absolutely no change between the data, and that one is very similar to symmetric. Their mean, median, mode is the same, but we don't see this one very often. Usually you'll see right skewed, left skewed, or symmetric.